Yay, you had an easy moment for a second, okay? But that's because that took us back to Algebra 1 for a while, so that was nice. But now we need to take it into the next level, into our Algebra 2. And this is when one or both sides have more than one fraction. And if it has more than one fraction, then that means that you have to get that common denominator. Okay? So that's what we've been doing for the past week or so, is we have been finding that common denominator so that you can get one fraction. You put it all together so that you only have one fraction. Okay? So when you look here, when you look at this problem, we only have one fraction on the right, but unfortunately we have two fractions on the left. So this is the case where we need to follow these two parts. Get a common denominator for all of them, okay, which is going to adjust the numerators so that we can put it together. Then all you actually have to do is solve the numerators, okay? Because you can do what you can remove the denominators by multiplying it on both sides, and that will cancel it out. But really what ends up happening is that we have the numerators and we solve them, okay? So we're just going to take it from that standpoint. So when you look across these three fractions, okay, let's go off to the side and let's list the common denominator. So I'll say CD for common denominator is 4x, okay? That way they all have a 4x. So when you look at this first fraction, if the common denominator is 4x, or if you ask yourself, what is this missing compared to this one, it's missing the 4. So let me put in these little parts real quick. And this one. Alright, so this one is missing the 4. Okay, and if we decided it's 4x, because that's what all of those could change to, since this one's missing the 4, we already have the 5 up here, we already have the x, so now we need to multiply top and bottom by that 4, and you guys are used to that. Okay, you're used to having to change the bottom. So this one has the 4 with it, so it is missing the x, so let's multiply top and bottom by the x. And then this one has a -9. I'm going to move the negative up to the 9. And an x, so it is missing the 4 as well. So, okay, you want to multiply that 4 in. So when you multiply 4 to the first fraction, x to the second fraction, and 4 to the third fraction, they're all going to match at this point. So we will have 4x as our common denominator on both sides, and that's going to help us out because then we can get rid of it. Alright? But that changes our numerator, and I put it right here. Adjust the numerators, so that's 20 plus 7x equals -36. Alright? Well, we really only have to solve the numerators. But the reason why is because if you've got something in the denominator, whenever you have an equation, whatever you do to the left side, you can do to the right side. So if I multiply the right side by 4x, I can do it to the left side, and what happens is that actually cancels those out. Now you don't have to do that. Once you get this common denominator, you can just jump to the numerators and just solve it. Okay? I was just showing why, in case some of you guys are wondering why we're getting rid of the denominator. It's because you could multiply it out. The inverse of dividing is multiplying, so you could multiply it and it would go away. But really, we just focus here on the numerator. From here on out, it's pretty easy. A two-step equation, 7x equals -56, and x equals 8. Alright? Now, this other part says, check for extraneous solutions, because denominators cannot be 0. Okay, so if our x is 8, and we put an 8 right here and an 8 right here, well, that works out fine, because that means that it's over 8, no zeros, so 8 is our answer. Alright? So then this one, our common denominator, our CD will be y minus 2. All right, that's the only denominator we have for that one. That means we need to change that one. So let's take our track so we can organize our left side and our right side. The nice thing about this being our common denominator is that we don't even have to change two of them. Both of these are ready. They're already 2 over y minus 2 and y over y minus 2. So the only one we have to change is our first one. Y over doesn't even have anything, so that means we need to multiply. Let me do it in a different color. We have to multiply y minus 2 on bottom, and that means we also, let me move it over, have to multiply a y minus 2 on top. Okay? So the y right here is here from the beginning. Okay, but in order for its denominator, which is an automatic 1, but that really, you don't have to write it, in order for this to match those denominators, you needed to multiply y minus 2 on the bottom. That also means we had to do it to the top. So now we have to clean this up. The nice thing, again, since now they match, we could multiply by y minus 2 across the board, but that's silly. We don't really need to do that. We can just get rid of it. So right now, let's put the numerator together. Y times y is y squared minus 2y plus y. So I distributed for those two plus that y that was already there over 2. Again, the common denominator is y minus 2. And we really can just throw it out. We don't need it anymore. Now that it's adjusted the numerators, if I multiply y minus 2 on both sides, it would go away anyway. Now we can just focus on the numerators. So once they match, you can throw them out. We would get rid of them by multiplying. So this is y squared. Put those two together is minus y. And then, because we have a squared, it's quadratic, which means we need to solve it by factoring or quadratic formula or using our calculator, graphing it however, but that means we need to say equals 0. Okay, and this y squared jumped out to me and I said, oh, I need to factor it. I needed to say equals 0 in order to get 2 answers, because remember the y squared means there's 2 answers. So if you want to think to yourself what multiplies to negative 2 and adds to negative 1, that is a negative 2 and a positive 1. So that's y minus 2, y plus 1. Okay, now this takes us all the way back to factors and their solutions. We're solving now, that's why it's a different SOL. So we're solving, remember, the solutions are the opposite of the factors. These are the factors, this times this, so these solutions are the opposites. So it would be a positive 2 and a negative 1. Alright, and just like I talked about over here, right here, we want to make sure that a 2 or a negative 1 does not make this a 0. Okay? So if you were to put a 2 in right here, what would 2, if we were to put a 2 in right there, what would 2 minus 2 be? Uh-oh, that gives us a problem. That would be a 0. 2 minus 2 would be a 0. We do not want that. Okay? We cannot ever have a 0 in the denominator, so that is not our answer. The only one that is our answer is that one. Okay? So always just make sure that that number does not give us a 0 down in the denominator. So even though there should be 2 answers, one of them didn't work. It's extraneous. It's an extra answer that actually doesn't work out for us. Alright, so this last one. Okay, remember, if we were to factor that, factor first, factor last, we've been doing that for a while. Okay, actually, let me take a break just for a second.